Hey everyone, my name is Talon McFly. Today I want to talk about a possible next generation of computing systems, temporal processors. Processors as machines that handle numbers, instructions, and matrices. First came transistor architectures, then vector and matrix designs. Later, quantum processors emerged, where computation deals not with definite values, but with probabilistic states. Now imagine a system that doesn't just process data in space, but treats time itself as a computational parameter. From vision to imagination. The first eye, back in the Cambrian period, was only a light-sensitive spot. It couldn't see shapes or depth. It simply responded to light and motion. That was minimal, but it began the evolution of vision. Over time, organisms learned to perceive space, first shadows, then direction, then distance. Human vision is among the most advanced, but what truly sets us apart isn't what our eyes see. It's what our minds imagine. It lets us design, simulate, and create what doesn't yet exist. When an engineer works in Fusion 360, or an artist sculpts in Blender, they rely on an internal model of space, not on sight alone. Yet, even this perception has limits. We live in a three-dimensional world, but our eyes receive a two-dimensional image. Depth is an illusion reconstructed by the brain. A simple experiment. Ask someone to toss a spherical object, like a ball, somewhere in the room while you stand with eyes closed. Then, try to locate exactly where it landed using only sound. If you succeed, your brain is building a precise 3D model of space. If not, that's normal. It shows the limits of perception. Now try a second part. Have the same person slide a flat object, like a coin, across a tabletop right beside your ear. You'll find it far easier to track its position. Our hearing and brain naturally handle this two-dimensional surface. True 3D localization requires complex reconstruction. This reveals that even our spatial perception is a model, not direct reality. Adding the fourth dimension. Now add a fourth coordinate. Time. Can we perceive it directly? We live within time but don't control it. Everything we sense, light, sound, pain, arrives with delay. Even in the present, we interact with the past. If we could perceive time as a coordinate, we wouldn't see a single instant. We'd see trajectories, streams of change. In physics terms, that becomes computation, not perception. What is a temporal processor? Modern processors handle discrete states. Input arrow operation, arrow output. Quantum processors work with probabilities and superpositions. A temporal processor, hypothetically, would operate on dynamics, where results depend not only on what the state is, but on how, when, and how fast it changes. It wouldn't just store data. It would process temporal dependencies, the rhythm, flow, and evolution of processes. Such computation could transform physics simulation, biology, and artificial intelligence, where behavior depends on continuous change rather than static values. Material foundations. To build such a device, we'd need matter that interacts with time in a structured way at the quantum level, matter with stable temporal symmetries. Extreme states such as quark-gluon plasma, neutron-degenerate matter, or materials under immense pressure and magnetic fields, like inside neutron, stars, exhibit unusual temporal behavior. They don't sense time. They evolve within it in stable, periodic patterns. A real example is the time crystal, a structure that repeats its quantum state at regular intervals, breaking ordinary time translation symmetry. It doesn't control time or enable time travel, but it proves that temporal order in matter exists. If effects like this could be integrated into circuits, computation might depend not on static logic gates, but on temporal rhythms. Why this matters? Conventional computers calculate static states. Quantum computers explore probabilities. Temporal processors would model change itself. Instead of asking what will happen, they would simulate how it unfolds. That's a shift, from static algorithms to temporal computation, where results live not in memory, but in time. Conclusion. We can't yet control quantum fluctuations or build temporal processors, but the direction is visible. When humanity learns to engineer matter where time becomes a computable dimension, it will be not just a technological leap, but a conceptual one. We'll stop viewing information as isolated data points. We'll begin to see it as flow, as meaning moving through time. My name is Talon McFly. This was a glimpse into a possible future of computation, in time. See you soon.